This is a key to the worksheet on topic 20, radicals, and this is the worksheet called Extra 7. And so you want to rewrite in each of the following, you want to use radical notation to rewrite these expressions, and then you want to simplify your answer. If the expression cannot be simplified, then just write the word can be simplified in here. Okay? All right, so the first thing you do though is going to rewrite each one of these in radical notation, and then you're going to simplify. Whatever you have here, you're going to simplify. Okay, now before we go on, let's remind ourselves about this property. So remember, there were a couple of properties that you learned dealing with rational exponents. Okay, so one of the properties you learned was this: if you have b to the let's say 1 divided by a, then see how you have that 1 in the numerator, then that's just the a root of b. So the base becomes your radicand, and the denominator of your rational exponent is your index. Then we extended that to something like this. I'm going to write this as c over a, just to keep the b and the a consistent. So now the numerator is no longer 1. So we saw that we can write this. So remember, the denominator is still your index. So my index is a, so it'll be the a root. The base is your radicand. All right, so it'll be the a root of b. And then we saw that the numerator, if it's not 1, then that means I have to raise this to the c power. Or see how c is on the outside? I could put on the inside as well. So it'll be the a root of b to the c. But if you're evaluating, it's usually easier, it's a lot easier most times to have that c on the outside. Okay? All right, so that's what you learned in those lessons. So now number 1, you have 8 to the 4/3. Well, according to, now notice that this is not a 1, so we're going to use this throughout the lesson, or throughout this worksheet, we're going to use this one. So according to our property here, I can rewrite this as a radical, so you'd say the cube root of 8 raised to the 4th power. Okay, so the base is your radicand, the denominator is your index, and the exponent here of the irrational expression, the numerator here of the irrational expression, is the outside exponent. And so the cube root of 8 is 2. So I want you to notice that this would be your radical notation. And so then you would say, well, the cube root of 8 is 2, right? And then 2 to the 4th, 2 to the 4th means 2 times 2 times 2 times 2, which is 16. So that'll be the answer. So in number 1, you'd say radical notation, you'd say the cube root of 8 to the 4th, and your answer would be 16. Okay? All right, number 2, we have negative 27 raised to the 4/3 power. So same thing, radical notation, you would say the cube root of negative 27, all raised to the 4th power. So there's your radical notation. Then let's figure out what this is. The cube root of 27 is a negative 3. And I'm raising negative 3 to the 4th power. Now, if you're going to use your calculator, you better make sure that negative 3 is in parentheses in your calculator, because remember, this is negative, and that negative is raised to an even power, so my answer should be positive. So make sure you put that in parentheses. So parentheses negative 4, close the parentheses, I'm sorry, negative 3, and then raised to the 4th power gives us 81. Kind of makes sense because negative 3 times negative 3 is 9, and then you have another pair, so 9 times 9 is 81. All right, so number 2, we get the cube root of negative 27, all raised to the 4th power. And remember, you could have said this, I don't have enough room, but for this one, you could have said the cube root of 8 raised to the 4th like this, and that's the one I used. This is one I use to simplify. The cube root of 8 is 2, and then 2 to the 4th, 16. So for the rest of these, I'm going to put the exponent on the outside for the most part. Yeah, so that's what I'm going to use, and put the exponent on the outside. All right, and the answer here we said was what, 81? Okay. All right, number 3. Number 3, you have negative 125 raised to the 2/3 power. So my radical notation, you're going to say the cube root of negative 125, all raised to the second power. All right, let's think about what the cube root of negative 125 is. So that's going to be a negative 5, right? And if you don't remember, use your calculator. You have access to calculator. So the cube root of negative 125, so 3, and then this function here, and then negative 125, press equal, you get negative 5. So negative 5 times negative 5 times negative 5 is negative 125. So I get negative 5 squared, notice the parentheses, so negative 5 times itself is 25. So number 3, the answer is going to be here, radical notation. You're going to say the cube root of negative 125, all raised to the second power, and we said that this was positive 25. Okay, number 4. So number 4, we have negative 128 raised to the 9/7 power. Okay, and so this would be the 7th root of negative 128 raised to the 9th power. Now the 7th root of the negative 128, so use your calculator with that. And I want you to notice something. When I do that, and you see, if I would use a calculator all these, I would have gotten 2, the cube root of negative 27 is 3, and the cube root of negative 125 is negative 5, right? And so I could simplify all of those. But notice when I do that, let's see what happens. The 7th root of negative 128, right? Negative 128. Let's see if that's a whole number. Yep, it is. So the 7th root of negative 128 is a negative 2. And it kind of makes sense. Let's try this. So a negative 2 in parentheses, make sure you put parentheses, negative 2 in parentheses raised to the 7th power gives us negative 128. So that's negative 2. And negative 2 to the 9th power, now use your calculator with that. So negative 2 to the 9th power, gives us negative 512. All right. So in number 4, we have the 7th root of negative 128 to the 9th power, and then we got that to be a negative 512. Okay, number 5. So number 5, we have 25 divided by 64, all raised to the 3/2 power. And so as in radical notation, that becomes the square root of 25 divided by 64, all raised to the 3rd power. All right, so in terms of, now remember, you didn't have to show the work here. You didn't say anything about showing work. So all I needed was this and the answer. But in your mind, you have to do some work. So the square root of 25 is 5. The square root of 64 is 8. And then you have to cube this. And so use your calculator with that. So 5 cubed, now that one's easy. 5 to the 3rd power, 5 times 5 is 25. 25 times 5 is 125. But that one's not as easy. So 8 to the 3rd power, so 8 raised to the 3rd power gives us 512. And so that's what you put in the blank. So there's your simplified answer. So I get, so here this becomes the square root of 25 divided by 64, all raised to the 3rd power. And then we get 125 divided by 512. All right. Number 6, we have now be careful with 6. So look at what it looks like. So this is what 6 looks like. We have 3 times x to the 5/7 power. Okay? In radical form, notice that the only expression that's being raised to the 5/7 power to this rational exponent is x. See, if it was 3x, it would be in parentheses. It's not in parentheses, so it's just x. So this becomes 3 times the 7th root of x raised to the 5th power. Or for that one, it maybe look better if you do it like this: 3 times the 7th root of x to the 5th, like this. Okay, so since I only have room for one of them right here, I'm going to use this one. So this would be 3 times the 7th root of x to the 5th. Now, can I simplify this? Now, remember, one of our properties that you learned in the past was that see this exponent is 5. 5 is less than 7, so this cannot be simplified further. So that's the one where you would say can't be simplified. So you'd say can't be simplified. Okay? Make sure you read the direction. Direction says right, can't be simplified, so make sure that's what you do. Okay, now let's look at number 7. Number 7, so I'm going to write right here, sorry, can't be simplified. All right, number 7, we have this expression. We have x to the 10th, all raised to the 6/5. Okay, so now in terms of our radical notation, you would say the 5th root of x to the 10th, all raised to the 6th power. Now remember, the 5th root of x to the 10th, you've had many a practice with this. 5 is divisible by 10 is divisible by 5, so that's x squared. But x squared is being raised to the 6th power, right? And so when you have a power raised to power, you multiply those exponents, that'll be x to the 12th. So in terms of our radical notation, you would say the 5th root of x to the 10th, all raised to the 6th power, and the answer is x to the 12th. All right, so that's number 7. Okay, let's look at number 8. Number 8, we have, going to move this out of the way, and number 8, we have this. We have x to the 9th, y to the 6th, all raised to the 2/3 power. So in radical notation, this becomes the cube root, the denominator is 3, so cube root of x to the 9th, y to the 6th, all raised to the 2nd power. Now let's go ahead and simplify this. So when I simplify this, this becomes the cube root of x to the 9th. 9 divided by 3 is 3, so it becomes x cubed. 6 divided by 3 is 2, so it becomes y to the 6th, all raised to the 2nd power. Now remember, one of the things you learned in a previous course, that when you have a product like this and it's being raised to an exponent, then remember that this is the step that you did back then. Now most of you can skip the step now because you can see what this simplifies to, but when you first studied this is what you said. You said that's be x cubed squared times y to the 6th squared. You're going to square each of those, okay? And so basically you're looking at a product raised to a power. So that was that product power rule. And so when you have a power raised to power now, you multiply those exponents. So it'll be x to the 6th, y to the 12th. All right, so that'll be the answer there. So in terms of this answer here, the radical notation, you would say the cube root of x to the 9th, y to the 6th squared, like that. And then the answer is x to the 6th, y to the 12th. So x to the 6th, y to the 12th. Number 9. Okay, so number 9, we have 25, x to the 8th, y to the 4th, all raised to the 3/2 power. So in terms of radical notation, so that's going to become the square root. Now don't put the 2 there, so it's to be a 2. 25, x to the 8th, y to the 4th, all raised to the 3rd power. So that would go here. Now keep that in mind. Radical notation, that's your radical notation. So it'll be the square root of 25, x to the 8th, y to the 4th, all raised to the 3rd power. Now you got to simplify this to get that answer. So remember, the square root of 25 is 5. The square root of x to the 8, 8 is divisible by 2, so that's 4, so it'll be x to the 4th. Y, the square root of y to the 4th, 4 divided by the index 2 is 2, so it'll be y squared, all raised to the 3rd power. Now remember, this right here is the same thing like this. So you have 5 cubed rather. 5 cubed is 125. Then we have x to the 4th cubed, so 4 times 3. Remember, you have this. This is what you have. You have 5 cubed, then you have x to the 4th cubed, and then you have y squared cubed. That's what you have. So that's what this right here means. You're cubing each of those factors. So 5 cubed, 125. X to the 4th cube, 4 times 3 is 12. And then 2 times 3 is 6. Okay? All right. So that's going to go, that's your answer here. So 125, 125, x to the 12th, y to the 6. And then finally, number 10. So number 10, we have negative 27, x to the 15th, all raised to the rational exponent of 2/3. So we can always change rational exponents to radicals. So that's what we've been doing here. So it becomes the cube root of negative 27, x to the 15th, all raised to the 2nd power. So that's your radical notation. So that goes here, the cube root of negative 27, x to the 15th, all raised to the 2nd power. And so now the cube root of negative 127 is a negative 3, and the cube root of x to the 15, 15 divided by 3 is 5, but that's being squared, so be careful now. Remember that means, like we did here, that means I'm going to take negative 3, I'm going to square it. So remember, that means negative 3 squared. And this means x to the 5th squared. That's what that means. And so negative 3 squared is 9. And then x to the 5th, so when I have an exponent raised to a power, so that's 5 times 2 is 10. But some of you, since this outer exponent is very small, it's just 2, you could have said this as well. You could have said, well, that's negative 3x to the 5th times itself, right? Negative 3x to the 5th. Well, negative 3 times negative 3 is 9. X to the 5th times x to the 5th. Remember, you multiply like bases, you add exponents. 5 plus 5 is 2. So you get the same answer. All right, so the answer is 9x to the 10th. So 9x to the 10th goes here. Okay, so that is the key to this worksheet.